Hi guys, I'm going to do lesson 5B for the summary. This is to help you with your assignment. I'm going to do the two questions that they didn't provide you solutions for. They also gave you pictures of the graph. I'll guide you through how they got those points. So your first question over here, they want you to graph this equation that's in factored form. I told you to do questions 1 to 5, so hopefully you're able to recognize. Here for the first one, it's in factored form. This one's technically in factored form and it's also in Vertex form. They give you a solution for this. And then the last two over here, they're actually both in standard form. So I'll go through question 1 and I'll go through question 3. So for this first one here, again, it's in factored form. If it's in factored form, we know the most important things that they tell us are the two X-intercepts, and if this graph actually opens up or down. So let's look over here. Remember, when you're trying to find X-intercepts, we would technically say let y is equal to 0. And remember, we would make both of these brackets equal to 0. I need to state this no matter what. And then we can, so this one will actually become 0. And then I separate these brackets and I try to isolate here for x that will make this bracket or this expression equal to 0. So let's rewrite it. I have here, we don't actually need this. So this would be x minus 3 is equal to 0. So I'm writing this equation here. And then x plus 5 is equal to 0. So I want to know what value of x here or here that will make this whole expression equal to 0 because we're multiplying. So let's isolate for here. If this is negative 3, when I move it over, it's now going to read as positive 3. So this is my first x-intercept. If I have here that we're adding 5, we're now going to subtract. So this is now going to be negative 5. So here are my values for my two x-intercepts. So if I wanted to graph these points, one would be at 3 and 0, and the other one would be at negative 5 and 0. So here are my x-intercepts. So typically we're graphing 5 points. Well, I will show you how to graph with 5 points. You need a minimum of 3. 5 is just to kind of ensure that you have the correct shape of the parabola. So here, x-intercepts, that's for sure 2 points. An important point of our parabola is also the vertex. So if I have the two x-intercepts here, if I wanted to find the vertex, I need the axis of symmetry, and I also need the corresponding y value for that. So let's find our axis of symmetry first. So axis of symmetry. I'm going to take these two x values and I'm going to add them. So 3 plus negative 5. And if I want to find the middle, I'm going to divide it by 2. So here I have negative 5 plus 3. This is negative 2 divided by 2, which is going to give us negative 1. So that's the middle x value between the 3 and the negative 5. And as soon as I have my axis of symmetry, this will help me find my corresponding y value for the vertex. So let's write this. So for my vertex, I know I have right now negative 1, and we don't know what this y is. So let's try to find it. So if I have an x value at negative 1, where am I going to find the corresponding y value? I just have to substitute it in here into the original so I can multiply or find the product so I can find this y. So let's rewrite our equation with the negative 1 in there. So y is equal to 3, x minus 3, x plus 5. Anywhere that I see x, I'm going to input negative 1. So negative 1 goes here, negative 1 goes here. So I'm going to have 3, and if I have negative 1 minus 3, so I owe you $1, I owe you another $3, I'm going to have negative 4, and then here it's negative 1, and I'm adding positive 5, so I'm having less of a positive, so this is now going to be equal to positive 4. And now I just multiply these numbers throughout. So here I have 12, 16, negative 16, and then negative 16 times 3. Let me do some quick math here. 8, so 48. Yeah, so you can think of it as 12 times 4. That would have been easier for me. 12 times 4 is 48, and here I have it that it's negative. So if this is the corresponding y value, my vertex will read as negative 1 and negative 48. Okay. And what else would I want to find? I have technically only 3 points. So I have this vertex, and then I have my 2 x-intercepts here. I could also find the y-intercept. So let's try that as well. So let's move this down. Let's find the y-intercept in my second board here. So if I wanted to find my y-intercept, let's rewrite the equation. I would rewrite this equation, and instead we're going to say let x is equal to 0 over here. So actually, let me just write it down here because I have a little bit of room. So if I want the y-intercept, I'm going to say let x is equal to 0. So my expression, I'm going to have y is equal to 3, and I have 0 minus 3, and then I have 0 plus 5. So this is going to give me 3 times negative 3 times positive 5. This is going to give me negative 45 for the y-intercept. So my points for the y-intercept is going to be 0 and negative just 45, no point. And here, just because my axis of symmetry here is at negative 1, I'm going to find the corresponding y value. So let me show you all the information that I have right now. We can sketch it on our graph nicely. So let me draw what we have. They want negative 45. And it's opening up. So let me draw something like this. I want that space here because I know I'm supposed to go all the way down to negative 48. So let's plot our x-intercepts. Our x-intercepts, remember, we're at, back the board, 3 and at negative 5. And then I have my vertex at negative 1 and 48. And then I have this y-intercept at 0 and negative 45. So let me plot all of those points. Positive 1, positive 2, positive 3, and 0. So I'm going to plot a point here. I have negative 1, negative 2, negative 3, negative 4, negative 5. So here's my other y-intercept. My axis of symmetry was at negative 1. So let's draw that here. I'll draw my dotted line for my axis of symmetry. I'm going to go all the way down because I know I'm supposed to go all the way to 48. So again, we're just going to do a little bit of guesstimating here. This is going up by ones. I'll split this up into 5. So this is negative 10, negative 20, negative 30, negative 40, and then negative 50 would be somewhere here. So for my vertex, let us plot, I'll do this one in green, 0 and 45. Negative 1 and 48. So negative 1 and 48 will be my guesstimate, which is somewhere here. And then I had a y-intercept at 0 and 45. So let's plot that one as well. So 45 would be somewhere over here, halfway. And since I only have these 4 points, So I have a vertex, y-intercept, I have this two x-intercepts. Again, remember in the previous videos for C, if this is x is equal to -1, and this is 1 unit to get to 0, if I want to get the other point on the other side, so x is equal to 2, it should give me the same point over here. So it should be somewhere over here for 2. Make sure that those line up. Mine's a little bit off. So let's be a little bit more accurate, even though it's a sketch. And then algebraically, I'll check it with you guys. So our equation was y is equal to 3, 0 minus 3. Oops. And this is x plus 5. So I'm going to try that I'm going to let x is equal to -2 and see if I also get the same height at -45. So let's substitute that. Y is equal to 3. I'm going to have -2 minus 3. And I'm going to have -2 plus 5. So this gives me -5. And this is going to give me +3. So 3 times 3 is 9. 9 times -5 is going to be -45. So I'm happy with this answer that at -2 and -45, this is the corresponding point that is over here. So this is -2, -45. So now that I have my 5 points, I can happily sketch our parabola. I don't have any other colors, so let's just do it in red. So it's very visible. Again, our parabola that's opening up. It's more narrow. It's going to look something like this. And you can check on Desmos to see if that's actually accurate. So let's bring up our Desmos graph and let's check all of our 5 points to